Hi, DD Solar here. Thanks for tuning in. In this video, I present some clips I recorded over a long period of time. I'm working on a project to cover up my roll-up door. As you probably know, roll-up doors are loud, rattly, cheap, and nearly impossible to seal. I'm sure there are more expensive roll-up doors out there, but the normal kind that are installed on normal metal buildings are just not very good, and they leave much to be desired. I insulated my solar workshop with 2-inch thick foam board insulation. It cost me a fortune. It took many weeks to install. I was by myself. It was a ton of work. I thought it would never end. And so I went to a lot of effort to create a workshop which is going to be conditioned. And I don't want it to freeze in the winter, and I don't want it to burn up in the summer. But here you have this gigantic 8-foot by 8-foot roll-up door, plus all the metal surrounding it. And this thing has no insulation whatsoever. It has no sealing whatsoever. It cannot be sealed out. It is full of leaks and air gaps. And it simply radiates in the summer heat directly from the outside. It's almost like you might as well just roll the door up and let the summer come right on in. In the window, I have a single 5,000 BTU window air conditioner. My building is approximately 20 feet by 30 feet and has a 13-foot high peak on the roof. And you might be wondering, how in the world can a 5,000 BTU air conditioner condition such a large building? And the answer is, from the very beginning, I was thinking about this problem. I planned to use a small air conditioner in this large building. My strategy was to do everything I possibly could to tilt the board in my favor. So the first thing I did when I had the building built, most people use double bubble insulation on a metal building, which has basically no R value. I opted for a different product. It is a foam back product with a radiant barrier. It has a minimal R value. Not very much, but it's far superior to double bubble insulation. It also costs a good amount of money, but I really don't think it costs that much more, if at all more, than double bubble insulation. So I'm very satisfied with that choice. That decision was very wise. But the real bonus that this material gives is it produces a thermal break between the metal sheathing or outside skin of the building and the metal posts which make up the frame of the internal parts of the building. This is critical because a metal building is simply going to heat up in the sun, and that heat is going to radiate right into the interior of the building, and there will be nothing to stop it. By placing a layer of actual foam between the metal skin of the building and the metal uprights or posts or frame of the building internally, this guarantees a somewhat limited thermal break. It does not stop all of the heat, but it stops a lot of it from conducting into the interior of the building. This is one of the #1 flaws of a metal building. The metal skin conducting straight into the interior and heating up the interior. Behind that insulation product, I placed 2-inch thick foam board insulation. If you're interested in seeing my installation of that product, I did record some clips of the process. Obviously, I'm a one-man show, so I couldn't do a lot of camera work, but I do have a video about installing foam board insulation. The 2-inch thick foam board insulation has an R value of approximately 10. Of course, it's debatable what the actual R value is, but the bottom line is it's 2 inches of very thick foam. That is significant insulation. And most metal buildings have no insulation of that sort at all. From the very beginning, I wanted to condition this workshop, and so my strategy was to put as much insulation in as I could, and to find any corners I could cut to enhance the thermal properties of the building. And hopefully without spending too much more money. Obviously, the foam board was very expensive, and it has done nothing but go up in price ever since. In fact, the boards that I have left over now are now worth even more than when I bought them. Now, the windows and doors in a building are typically places where heat loss can occur in the winter and heat gain can occur in the summer. But the roll-up door is the biggest offender of all. It's basically just a big metal sheet with no insulation whatsoever. In this project, I decided to frame out my roll-up door with common lumber. The structure is about 9 foot high by about 9 foot wide and is using mostly 2x6 to create the construction. I did use some recycled scrap 2x4 material. It is anchored to the metal uprights of the building using self-drilling screws and wood screws and very, very strong L brackets, which were intended for the construction of metal buildings, so they're more than strong enough for this kind of creation. I tried different methods and ideas for insulating and sealing off the roll-up door, but I finally came to the conclusion that you cannot seal a roll-up door. You can partially seal it, you can reduce the air drafts, you can partially insulate it, But the bottom line is it was never intended or designed to be sealed and even insulated. One way to get around that is simply to frame in the roll-up door, which is what I eventually was forced to do. The frame is built with 2x6 unpressure treated lumber. Where necessary, the 2x6 has been notched where it makes contact with the steel footer going all the way around the base of the building. The 2x6 is notched so that the footer can fit underneath. Where the 2x6 framing rests on the concrete, it is protected by an application of a concrete sealer as well as a building tape, which is applied to the bottom and wrapped around the bottom of the 2x6. In addition to that, there is a bead of Dowsil metal building sealant, which is run right along here, and I will probably add more of that later on. It's also over here, and that's just to prevent water from creeping in and damaging the wood over time. The framing goes all the way up to about 9 feet in the air and creates a rectangle shape over the top of the roll-up door. It's high enough so that when the door rolls up, there is no interference whatsoever. In fact, there's a gap in between, so there's plenty of room for the door to roll up and still have access to that area. Roll-up doors sometimes need service, lubrication, maintenance, or adjustment, and so it's important to not close out those options with any kind of framing. I have access to both ends of the roll-up door if I need to, and so I'm not closing myself out if I need to do maintenance in the future. Construction was done with this type of screw. This is a structural screw, as well as normal deck screws. I mostly use the structural screw. This is a 3-inch version. The whole frame is attached using metal building angle brackets and self-drilling metal screws so that it can't move. To protect the 2x6 lumber from carpenter bees, it has been wrapped in a radiant barrier material which I had available. This will reflect some of the heat in the summertime, although that is not its exact purpose. Carpenter bees will absolutely find their way inside, and they will absolutely damage the wood over a period of years. And so it's better to cover the wood with something that is robust and will not allow the carpenter bees to damage the wood. I could have used paint, but in my experience, even painted wood is no contest for carpenter bees. They'll eat into it anyway. So my hope is that this very tough metal and plastic barrier with ripstop in it is going to be pretty much impossible for carpenter bees to damage. All of the wood surfaces are covered with this material on the inside, where they will be exposed essentially to the elements, because I'm going to close this whole thing in. The first phase of this project is actually complete. Unfortunately, I was not able to show the work being done. It is really very much like framing a building, and so nothing really exciting. The next step is to attach a roof or a board of some sort to cover the top. Once that's done, there will also be essentially heavy-duty curtains, thermal curtains, which are going to hang down from the top part, which is right there. And that will be the first phase of construction. Now later, I will probably come down here with additional framing right around here and bring it straight down. I would then be able to build myself a set of doors. However, right now, there's too many things going on, and the quickest way to cover this roll-up door is actually to install heavy-duty thermal curtains, which I'm going to have made myself. The solar workshop has been insulated previously with 2-inch thick R10 foam board. Now with all that work, all that expense, and all that effort, it's a real shame to have what is essentially a part of the wall, 8 foot by 8 foot, which is completely uninsulated and is letting in large drafts. It allows in a lot of humidity, it allows in bugs and insects, and it's the biggest flaw right now in this building. I completely gave up on trying to seal and insulate a door like this. I realize it is a futile effort, and I'm not going to waste any more time on it. The bottom line is that these doors were never intended to seal out the elements, and they were never intended to be insulated. Mostly they're just a physical barrier to humans and larger animals. In the summertime, you want to control the humidity. Well, with a door like this, it's like leaving your door open cracked all the time. It's got lots of places for air and humidity to creep in. So while your air conditioner is struggling to remove the humidity from the air, which is one of its primary jobs, more humidity is coming in all the time through the roll-up door and cannot be stopped. Part of this build strategy will be to block and seal out drafts and moisture coming in from the outside in the summertime. In the wintertime, of course, that will also help It will keep hot air from escaping the building after it has been heated. In addition to that, metal is pretty much a perfect conductor of heat and cold. So the problem here is that in the wintertime, your heat is going to be going straight out that door. It's going to conduct into the metal door, and it's going to radiate into the outside air in the winter. In the summer, even though the door is white, whether the sun is hitting it or not, it is simply going to conduct heat inside the building. When the sun does come around and strike the roll-up door, it's going to get quite warm and act as a gigantic heating radiator inside the building. So now the air conditioner has to struggle to also remove that additional heat. So roll-up doors are really, really bad if you're trying to make a conditioned space. They waste a lot of energy, and there's just a lot of issues with them. Now, I was forced to get this roll-up door. I would rather have had some other kind of arrangement, possibly a standard or classic garage door with insulating foam on it, or possibly even just two double doors that open in a French door style. But I have what I have, and I'm stuck with it, and I have to find a way to seal this out and complete the insulation and create the insulated conditioned envelope that I've been looking for in this building. As soon as my roof is on the top of this frame, which I have not installed yet, that will go right on the top here, right in this area here. That will be closed off with a sort of roof. It's also going to have the same radiant barrier film attached to it to protect it from bugs and insects, hopefully to make an inhospitable space for any insects that do get in. It's funny how even a sheet hanging over a door can provide some insulation and provide some control of the airflow, while a thick, heavy curtain is going to do even better, and it will hopefully block some of that heat. I'll probably try to install some sort of radiant barrier as well, and then the air conditioner won't struggle so much in this building. To attach the radiant barrier material, I used my Ryobi 3/8 inch crown stapler. It worked pretty good, and I'll definitely be using it again for more projects in the future. On top of the frame, there is going to be some plywood, which is then wrapped in this radiant barrier material. The material is stapled on top of the plywood, and that creates sort of a roof which will reflect some of the heat. The roll-up door will collect a lot of heat when the sun hits it. This heat will start to rise up naturally, and in general this is going to reflect some of that heat back down, and the entire area is going to be insulated. The heat will be greatly reduced from entering the shop itself. Here you can see part of the roof, or most of the roof, has been installed. There's only a small area right here in the corner, which you just saw, that I'm going to be installing. And the next step will be to attach the thermal curtains, which really are a temporary step. Eventually this entire door will probably be framed in, and there will be some sort of a door behind it, a wooden door, probably with insulation. But right now the thermal curtains will give me a quick escape from the heat that's coming in from this roll-up door. Hopefully my air conditioner will perform better. The combination of all the radiant barrier I am installing, as well as the thermal curtains, and the ability to seal out the drafts and humid hot air coming in from the outside, should really help. Here is a closer look at the inside of the frame and roof that I'm building over the roll-up door, and you can see that the entire area in there is coated with a radiant barrier. This is to prevent carpenter bees and discourage them from attacking the wood, which they will do, absolutely. Of course, some insects can get in here. There's no way to stop them all. I have ways to reduce it, but I can't really stop them. So I have to cover the wood in here and protect it. Any heat that comes up in here is going to be reflected back down, and I hope that helps. You can see the entire area inside is coated with the radiant barrier. Let's see if I can get the camera in there. The entire thing. Both ends have this doubled up 2x6, which is going to support the weight of any curtains or anything that I hang from here. Eventually I'll probably install additional framing, but right now I'm not going to do that. And these are plenty strong enough for what I'm going to be doing. This is a Harbor Freight blanket, which has been rolled up and tied with ropes, and I use that to block some of the insects and hot, moist air from coming in. There's a big gap at the top of a roll-up door, unfortunately. As far as I know, most of them have it, and it's really hard to seal. So that's why I decided eventually, with all these holes and gaps, you can see light coming in. There's light coming in there. There's all kinds of gaps. So that's why I decided to go ahead and frame it in. You can see all the light that's coming in there. There's light coming in here. So all I can do is reduce the drafts that are coming in. The frame that I'm building is going to be where I actually do the sealing, block the hot and moist air from coming in, and ultimately block any insects from entering the structure through this door. They will end up inside this area, and there's nothing I can do about that. This is the radiant barrier material I'm using. It's a very high quality, very tough material with a ripstop in it. It's easy to work with, it staples well, it's also very reflective as you can see, and it's very heavy duty. I'm going to be using this to further treat this frame and block the heat from coming in. But doing the radiant barrier at the top and on the sides is a good start. I decided to try to reflect as much of the heat as I can, so I have a plan on how to use this material. It's not just to protect the wood from insects. I'm going to go ahead and use it to reflect the heat as much as I can. And I have some ideas, which I'll be showing hopefully pretty soon here, how to use this material to reflect most of the heat right back out where it came from, outdoors. And the way a radiant barrier works, this material, because it's metal, it's got a metal coating on it. It's not actually touching the hot door. The door will radiate heat at this material, and the material will reflect it right back where it came from, most of it, and it'll go right back out through the door. And so the heat will be mostly blocked by this material, even though it's very, very thin. Radiated heat will just be sent right back where it came from. But you have to have a gap, an air gap. It can't be physically touching anything because that would be conduction. You would be conducting the heat right through this and it wouldn't stop it. But this will reflect radiated heat, most of it. It'll reflect it right back. But there it is, one half of it up. And now I'm waiting to put the other blanket up. I'm not going to do it right now. Hopefully that will reduce the heat coming in. It's not finished. The blankets will help keep the heat out until I'm able to finish. Okay, there's light at the end of the tunnel. This is the first side of the thermal blankets or curtains attached. Now I've chosen not to install the left side yet because it's too hard to get camera footage or take any pictures or do anything in there. And also at the top of the door there's a new device which I've installed, and I'll show that in a minute. Now a word of warning, if you want to use Harbor Freight blankets, they're very easy to tear and rip. It's not sufficient to attach them with screws. Those will just tear. So I'm going to eventually have furring strips attached over the top of the blankets. I have not done that step yet, but it's very straightforward. You would simply place a strip of wood right over the blanket right along there, and that will help secure the blanket. They're very easy to tear, so you have to be very careful with them. I deliberately left some of the blanket draping on the floor, and although that doesn't look too great, this is to provide a rudimentary seal for air, to keep air from coming in or going out. Now in the winter time, what I'll probably do is lay something on top of there, because I won't be using this roll-up door very much in the winter, if at all. In the summer I do need access, so I probably won't be putting anything on there. Of course I don't want water to come in, so I would have to make sure these blankets stay dry. On the other side of the blanket there is a layer of the radiant barrier, and that is attached using the pieces of 1x2, which you can see here. And there's another piece right on the other side of the blanket, and then there's radiant barrier, and that's attached with 2 screws. What that does is give a very secure way of attaching the radiant barrier to the blanket. It also helps protect the blanket from tearing, and the radiant barrier is actually attached in such a way that if you pull on the blanket, it actually pulls on the radiant barrier. And the radiant barrier is very, very strong. It's very hard to tear, so it helps protect the blanket from accidentally tearing if it is pulled on. So here is a side view and a cross section of the construction. First you have the blanket, which is here. In between you have a 1x2 strip, and then you have the radiant barrier. And what this is doing is providing some standoff so the two materials are not in good contact. It's important to have this standoff because in the winter the effect would be opposite. You would want the heat from inside the structure to be bounced back into the structure. If the radiant barrier is touching the blanket, that effect will not work. So it's important to space the radiant barrier away from the blanket for both summer and winter use. Now I'll just pull the blanket back so you can see. That's the radiant barrier on the other side. Of course I'll probably put a little more effort into attaching it, but that's good enough for now. In addition to that, the radiant barrier is already pre-tensioned so that if I pull on the blanket, it's actually going to pull on the radiant barrier. And this stuff is tough as nails. It's not going to tear very easily unless somebody hangs on it, which I won't be doing. Trying to get some better footage of the construction detail. If you come around here, you'll see there's a radiant barrier, and it's attached to the inside of the frame. Hope that's clear. And it goes all the way down almost to the floor. I don't quite have it in hard contact with the floor, and I might trim it a little bit extra. It's not necessary. Now there is some gap there that isn't covered with radiant barrier. I can always cover that later. And right now I can feel the heat in this space. There's a lot of heat in here, and it is working. It is pushing the heat out. Of course I haven't done the left hand side, but if I had done the left hand side, it would have been a lot more difficult to work on this and finish the structure because the left-hand curtain would be in the way. If I pull back, you can see there's in between. There's the wood block in between the blanket and the radiant barrier. It's attached using small stainless steel washers and deck screws. And the screws are the right length so that they don't they don't protrude through the other side, so there's nothing sharp sticking out. And those are just pre-drilled blocks of 1x2 wood. And I will probably add more later, it's possible. But right now, that's all I needed just to get me up and running. Now, the other reason for not putting the left-hand curtain on right away is to work on the device, which is, you can't currently see it very well, but it's at the very top of this roll-up door. And there's not a lot of light coming in the top of the roll-up door. And that's because the device that I put up there is actually sealing out the light. Over here on the left-hand side of the door, you'll see a rope. So this is the rope. This is just some rope I got at Harbor Freight. And it's going all the way up to the very top of the door. And from here you cannot see that there's a series of pulleys which are going all the way across 9 foot from one side to the other. And this rope is attached to all of those pulleys. There you can see one of the pulleys. It's right there at the top left corner of the frame. It's right there. The pulleys go all the way across, and it's a little hard to see because they go into the dark area here. They go behind the right-hand side, but they go all the way across. And you can see that there's some light coming in, and actually I could make that almost zero if I wanted to. And what that is, that's just a Harbor Freight blanket that's been rolled up, and it's been attached to some ropes. I will probably make some changes to this later, but when I pull on that rope I showed you earlier, all of those pulleys there lift the rope and it tightens up and lifts the blanket up off the door. And I'll try to get the camera in there and show some better footage. And I don't know how good that footage is going to be. You can see the blanket just hanging there. So you can imagine if I pull on this rope, it just tightens up and then the blanket will basically lift a few inches up. It gets out of the way of the door. And what this blanket does, it just creates sort of a seal. It's not a complete seal, but it's enough to discourage insects from going inside. They will of course find their way in. Having a gigantic opening at the top of the door is just an invitation, so closing some of that off makes a lot of sense. It also blocks some of the draft, reduces the pressure of the draft that is going to come in, and anything you can do to reduce the draft that's coming in before it gets to the curtains is good, because since I haven't finished framing the opening, wind could come in and push at the curtains. So the less draft, the less pressure on these curtains, and the less chance of air forcing its way inside that is unconditioned. And right here is a couple of screws with tape wrapped around them. What happens is I just pull on this rope and I can wrap it around here and then wrap it around this screw here, which has a rubber washer on it, and that locks the blanket up into the air so I can open the door. In order to get through the summer, the final step will simply be to attach the left side curtain, which will have the exact same construction as the right hand side, so there's really nothing to show there. There are a couple of more details that I'll show that I'm going to be working on. First is, in order to create a really good seal between the framing and the wall of the metal building, and that's right here, there's always going to be a little bit of a gap here where the frame is up against the building because the wood isn't perfectly straight, neither is the foam board, so there's going to be a bit of a gap. And what I'm going to do is I'm going to take what's called building tape. It's this stuff right here. This is a very high quality metal tape. It has an extremely aggressive adhesive on it. It's an acrylic based adhesive, and that's just going to go right here where this seam is right here, and that will ensure a really good airtight seal as much as possible along the length of the framing. Next detail is I'm going to make some tiebacks for the thermal curtains. Probably will use this type of rope here or something similar, and those are just going to be on a hook, so I can simply pull on the rope, wrap it around, and hold the curtain back. Of course I won't lose some of the access of my 8-foot roll-up door, but I actually don't care because I never bring anything in here that's 8 feet, and I don't really need that. It's not really a problem for me. The other detail is that blanket that's at the top of the door that's rolled up. Probably will have some weights added to it, and I need to work a little more on it because it's not quite straight, and so it doesn't seal as well as it could. So I could definitely make the seal a little bit better. It's not the end of the world, but I will probably spend some time on it and try to improve the seal. Even though the door is partially uncovered, the radiant barrier and the blanket are already making a difference and stopping quite a lot of heat from entering the building. Of course, I need to seal it off and install the left-hand side to get the full effect. I have not yet decided how I'm going to seal the two blankets together. They are going to have approximately a 10-inch or 12-inch overlap. I may install something like a giant zipper. I'm not really sure. But I'm not too worried about it because I can push the two blankets together and they will seal good enough for now. And this is designed to get me through the summer until I can install a full wooden frame and probably some kind of nice wooden doors. I'm not sure exactly what the future will hold, but certainly now that this frame is up here, I can always take these blankets down and continue construction. So that would be phase 2. This is really almost an experiment to see how quickly you can get a barrier up to cover a roll-up door. This was not too bad. It wasn't too expensive. The total cost is probably not even $200. It's a few 2x6s. The blankets are $20. I'm going to say it's right around $100. Of course, quite a few hours of time and labor are involved. So phase 1 is nearly complete. Phase 1 is just thermal blankets. Phase 2 would be removal of the blankets, a little bit more framing, and some wooden doors. But that's going to be farther down the road, and hopefully this will get me through the summer, and also maybe even part of the winter as well. And just to be clear, I don't recommend the Harbor Freight blankets to be used in this manner. It was just what I had available. They're actually quite fragile and tear easily, so I will have to be really careful with these blankets and how I pull on them. A better choice might be a survival tarp that has a radiant barrier already attached, or just anything that isn't made out of very thin material that tears easily. These blankets are probably going to last me a long time if I'm careful. If I'm careless, they won't last very long at all. They will tear at the drop of a hat. Okay, it's on to the final step, which is going to be just install the left-hand side blanket, which is a mirror image of the right-hand side. And that's really about it. And this is the finished product for the summer, at least. Unfortunately, the blanket on the left was far more wrinkled, but it's not really about how it looks. And as soon as I covered this up, I noticed a difference. At the top, there's a furring strip, or simply a piece of wood to help protect the curtains from tearing. These Harbor Freight blankets are very fragile and tear easily. Behind the curtains are two large pieces of radiant barrier material, and that's helping reflect the heat back out. It made a huge difference. Once I covered up the doors, the temperature was much easier to control inside the building. And in fact, I turned down my air conditioner because I don't need it to run that hard anymore. Anytime I'm ready, I can tear these curtains down. I can create some kind of door to go over the finished framework instead of curtains. But right now, the pressing need is no longer there. These curtains are fulfilling the purpose of reducing my heating load and cooling load. They also stop some of the damp air from coming in during the summer, which is very good. Here I will test the temperature by aiming my IR thermometer. The temperature is about 78 degrees or so, depending on where I aim this thermometer. And that's the interior temperature inside the building. Now I'm going to test the temperature behind the blankets and the radiant barrier. I'm going to part the blankets and aim my thermometer inside to see what the temperature is. And I don't know if the camera will pick that up, so we will see how that goes. So the blankets are about 80 degrees, which is expected. 95.7 degrees in there. It is hot. I've stuck my hands in there, and I tell you what, it's hot. So these blankets, although they were cheap and they don't look the best, they are doing a very good job at blocking the heat coming through the roll-up door. This is the air conditioner I'm using for a approximately 20 by 30 building with a 13-foot high peak. It is a 5,000 BTU window air conditioner unit. Now on paper, a 5,000 BTU air conditioner should not be adequate for a structure that's this large. It's as big as a house, literally. But it has 2-inch thick foam board. The roll-up door is now blocked out with insulation. And as I expected, it doesn't take as much air conditioning as you would think to condition a workshop, it's all about insulation, sealing the air gap so the air doesn't infiltrate from the outside, and blocking heat, especially radiant heat, from coming through the metal skin of the building. Furthermore, the solar workshop is not completely insulated. There are a few areas on this side of the wall that have not had the 2-inch thick foam board installed. Yet despite that, a 5,000 BTU air conditioner is able to keep the workshop comfortable. Now today is not super hot. When it gets up towards 100 degrees, of course the air conditioner works a lot harder, but still the workshop is habitable. It's okay to come in here and work. It's not terrible at all. And that's shocking for only a 5,000 BTU air conditioner. Part of the reason for that is that the entire floor of the workshop is simply a concrete slab. The concrete slab is in contact with the ground all the time, and in the summertime it will help moderate the temperature of the structure inside. Now let's go ahead and zap the concrete with this IR thermometer, and you'll see it's right around 73 degrees, so it's obviously cooler than the air. So this concrete is actually helping to moderate the temperature inside the building, and that's a good thing. So I would consider the thermal curtains project and roll-up door frame-in project to be a success. It hasn't gone as far as I'd like it to go. Obviously I'd like a really nice permanent frame with a big door, some kind of door arrangement that I can open, but this setup will get me through the summer, and of course it will get me through the winter as well if I needed to. That should wrap up the video. I hope this video helps a few people out, maybe gives you some ideas about sealing up a roll-up door. It's probably better to try framing in the door than try sealing the door itself, as they are very, very hard to seal. Much easier when you have a rectangular or square opening around the door to seal that off instead. Thanks for watching, and I'll see you later.